Welcome to the channel. Yeah, I haven't been doing videos regarding my robot for some time due to my daughter that was born 4 months ago. So I've been quite busy with her, but I have still been working on the robot. So I'm just now going through what I've done so far. So I added to the robot, as I had had batteries inside the lower box for the arms and the neck actuators, all of these things, and I made a additional box of mine own here for lipos, where there are currently I can fit several lipos here for additional power supplies needed. And there's a bag here, charging bag in addition to this, and there's the cables coming out. I'm using these connectors here, XT connectors. In addition to that one, I modified the insides quite a bit. I changed the connection architecture in general. I put a different kind of Wi-Fi router here, one which is from one end connected to an external antenna and an internal antenna. There's the Rosco server as before. All the Raspberry Pis I've updated to ROS Melodic, and I've bought some new batteries here. Here's an Ethernet switch, there's a second one, and there's a third Ethernet switch. And I decided to disperse the transfer of data which contains images or video into one switch, and then mainly this one here, and then other like actuators and so on, they go through this one, and I can access the whole system through this one. This is like a central switch. And also these ones for the arm, I put them here. They're for the left and right arm. They're as usual read-only systems running ROS, Melodic, and I modified the ROS packages I made for them for the arm, slightly more suitable for reinforcement learning use. Yeah, a lot more cables, and make a lot more shorter. I also added for the rear battery, I added a new place here to conduct cables underneath here, hidden, protected inside this tube, which goes in the end into the lower box. One of the reasons I started doing these changes is I was working on the camera here. I got a new stereo camera. This is actually, unlike the previous where I had two cameras, which I was trying to sync inside the Raspberry Pi. That became too difficult and the results were not very good. So thanks to a friend of mine, he gave me a hint about a stereo camera I could buy from China, and I bought one where actually there's a chip which combines images from both of these cameras. Basically it's a circuit board like this, and unlike in many other stereo cameras, USB, where you connect with one USB cable to a computer, but it still provides two USB cameras, and that's kind of very difficult to sync. But this actually synced, so the chip on board the USB camera combines the two images and sends them as single one, so these are perfectly synced together. They're also quite high resolution, so it was around 2560 pixels times 960, and if it's motion JPEG packed, it's 60 frames per second, so it's quite a lot. Well, these cameras are nice. I got lenses for them, show you wide angle lenses and everything, but I ran into another problem after this. I was trying to push this through Raspberry Pi, and I realized that there are a lot of softwares for streaming available and so on, but decoding it and sending it forward into the Ethernet network, as I showed inside, doesn't really work well with Raspberry Pi. As in Raspberry Pi, the USB where this camera is connected and also the Ethernet connection are shared together. So it resulted that even though I had a software that just sends the motion JPEG images forward into the network and it's decoded elsewhere, it wasn't able to do it. It got stuck, it overheated, added more cooling to the systems and so on. So in addition, I actually tried an Asus Tinkerboard, and I don't know what happened to it, but it got kind of overheated and something went wrong with it as I was trying full speed decoding. Then I chosen this one, and there are a lot of others that can decode 4K image, which should be fine for this, or even just stream it through. But they require quite a different power supply where you can't use these small USB power banks anymore. Unlike this one, Odroid C2, this one should be able to stream it, theoretically. I haven't yet fully tried it. And it has a different chip, separate chip for the Ethernet connector, 1 gigabit from the USB. So theoretically this should not become a bottleneck anymore as it's in the Raspberry Pi. I will make a separate video of the demonstration when I manage to get this working. And also in general, my plan is now that I will just use one computer, the Odroid, to stream the motion JPEG image forward for different parts of those and the different neural networks. Also, recently I got some additional power. I have the Intel Movideo sticks which I bought before, and I'm planning to use them for the neural networks of the arms and the neck and the motion. But I realized this one had appeared for sale, Neural Compute Stick 2. Interesting enough, it's, yep, this way around. This one is actually not made in US, but made in China. Let's see, yeah. However, this one has quite many times the power of the single stick. Though at least online it seems that Intel is not supporting Raspberry Pi with this yet. I don't know if it's intentional or not, but there seems to be some other non-official attempts to make this work on Raspberry Pi. As it's the current consumption is the same, so I don't see any problem why it wouldn't work. It's the same size, just a lot more powerful than the previous sticks. So this will be an interesting one. I will make also videos of this one when I get to it. But first, before this one, I need to get the stereo camera image at 60 frames per second, if possible with a full resolution, forwarded to the rest of the system. Thank you for watching, and hopefully soon there will be more videos about the smaller details of what I'm doing here.